Good afternoon, grade 8. Before we continue, I want us to talk about the assessments that you are busy with. I hope everything is going well, and I hope that your tasks are clear, you are writing, and you are expected to submit today. You will submit by 22 hours today. This is what you're supposed to do. You are supposed to write your assessment and you are supposed to click a submit button at the bottom of your test, and that will send the test back to the school for marking. There is a warning that we really have to submit today. Please ensure that you do submit accordingly, because if you do not submit your test today by 22 hours, the school will deduct 20% of your mark. So you don't want to lose that much of your marks. Please, 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 I'm pleading with you. Do comply. If you to draw anything, you can draw the drawing and then on a piece of paper, and then screenshot the picture and send it to photos. Then click the bottom of the test right hand side, then upload. I hope that is clear. That is just a few announcements I wanted to make about your assessments. All the best, my children. I hope that you make it in this assessment. Yeah, welcome to this lesson for today. We are doing mechanical systems and control. We are doing the mechanical advantage and speed advantage, the speed ratio and mechanical advantage. Then we'll do calculations and gear drawings. Basically, what I mean is that we will recap and revise the work that you did yesterday so that you master it. And then we will go further to do drawings today. So I will not dwell much on the calculations, but I will bring them back for you to remember. I'll keep on bringing them back like that. Okay, these are the systems that we did yesterday of gears. Now, this is just an illustration of spur gears. You know, we have done different types of gears, and it's not the first time that you do gears, grade 8. You have done gears before. So we're just trying to remind you of the types of gears that you have done and maybe look deeper into the gears. So we are looking here at the speed advantage and the mechanical advantage of gear systems. Right, gears are basic mechanisms, as I explained earlier, that machines are made of systems of mechanisms. So a mechanism is the basic part of a machine. Looking at these two gears there, yesterday we agreed that the bigger gear is double the size of the smaller gear. How do you know that? We count the number of teeth. In gears, the number of teeth become very important. If the the driver gear turns clockwise, which way will the driven gear turn? It will turn anti-clockwise because any two mesh gears turn into opposite direction. Right, we have counted the number of teeth. We know that this one has 5 teeth, the small one has 5 teeth, and the big one, very good in Nhlanhla, it will turn anti-clockwise because any two mesh gears turn in opposite directions. Right, now because we know that this one has 5 teeth, the small one, and the big one has 10 teeth. Now, the question is, how many revolutions will the driver gear need to turn to make the driven gear turn once? The driver gear, in this case, is the small gear. So what is important here is the revolutions. So if this one is the driver, how many times must it turn to make this one turn once? Grade 8. How many times? I'm sorry about that background noise. It's some people who are here a short while ago. So how many times? Okay, here's the question on the screen. How many revolutions will the driver gear need to turn to make the driven gear turn once? This is the driver gear, this is the driven. How many times must this one turn in order for this one to turn once? No, if the driver is the small gear, it is half the size of the driven gear. How many times? Twice, okay? Because it is half the size of the driven gear, so the driver gear will turn twice to make the driven gear turn once. So the ratio is 1:2, okay? Or just to put it practically, the ratio is with 2 turns, this one turns once. So it's 2:1, okay? Right. Why does this happen? Because the driver gear is half the size of the driven gear. Will the system give a mechanical advantage? How do you know? How do you know? Will it give a mechanical advantage? Is it mechanical advantage if the input is greater than the output? Is it mechanical advantage or speed advantage? Okay. Let's look at your answers. Okay. The rotational speed of the output gear is slower than the rotational speed of the input gear. The rotational speed of the output gear is smaller. It means that the turning force, mechanical advantage, is when the turning force of the output is bigger than the input. Speed advantage is when the output is faster. Okay, so it will give us a mechanical advantage. Okay, a large driver, and we have just changed, reversed the positions. Okay. Will the driven gear turn faster or slower than the driver gear? This is now the driver gear, and this is the driven gear, right? Will this one turn faster? Will the driven gear, this one, will it turn faster or slower than the driver gear? Why? It will turn faster. Why? Because it has fewer teeth than the driver gear. So for one revolution here, we get 2 here, and that's fast. Okay? So we have better speed here. So we have speed advantage on this gear, on this system. The driver gear has 10 teeth and the driven gear has 5 teeth. How many revolutions will the driver gear need to turn to make the driven gear turn once? Half. Very good. You understand now. Half. 1:2. Half a revolution. Okay. So this system gives us speed advantage, not mechanical advantage. Will this gear system give a mechanical advantage or a speed advantage? I have just given you the answer. It will give us speed advantage because the driven gear will turn faster than the driver gear. Very good. Okay, so in this situation, you have mechanical advantage because you have torque. Remember yesterday we talked about torque. That is turning force. You have a high turning force here. So that is mechanical advantage. But here you have speed advantage. The output is speed advantage. In the other system, the output is a bigger turning force. So that is mechanical advantage. Now let's just revise the idler gear. Will the idler gear turn faster or slower than the driver gear? This is the driver. This is the driver. This is the idler. Okay. What's your answer? I want to get to your chat. All right. Okay. The idler gear will turn faster than the driver because it has fewer teeth than the driven gear. It will turn faster. Yes. Yes, Katlaho, we are recapping. It's a recap. Okay. Will the idler gear turn faster or slower than the driven gear? Explain. The idler and the driven gear. What's your take? The idler gear will turn faster than the driven gear because it has fewer teeth than the driven gear. So the situation here is a smaller idler gear between 2 big gears. And because it has fewer teeth, and it is smaller, it has a speed advantage as against these 2 bigger gears. So will the driver gear and the driven gear turn at different speeds? No, they will turn at the same speed because they have the same number of teeth. Okay, for each tooth rotation on the driver gear, the idler gear will rotate 1 tooth and the driven gear will rotate 1 tooth. So this one is faster than these both, but these both, because they're the same size, they will rotate at the same speed. Will the driver gear and the driven gear turn in different directions? No, they will turn in the same direction. They will turn in the same direction because there's an idler gear. Here, yes, they will turn in the same direction because that's the job of the idler gear, to make the driver and the driven gear go in the same direction. The answer is no, Natalie, you're right. Okay. Okay. I'm just happy that you understand this part, so we can go past it. So we have the egg beater and the hand drill. Remember the egg beater and the hand drill that I showed you yesterday? Do you think the hand drill gives you a speed advantage or a mechanical advantage? Explain your answer. It gives you a speed advantage. Okay. It gives you a speed advantage because the small output gear will rotate much faster than the big the big input gear. Remember, the driven gear in the hand drill is a small gear, so that gives you better speed. Explain how the bevel gears work on the hand drill. How do they work on the hand drill? Both the big input gear and the two small output gears are bevel gears. This gear system changes the direction of rotation from a rotation around a horizontal axis for the big input gear to a rotation around a vertical axis for the small output gears. Remember, their axes are they are different. One is horizontal and the other one is vertical. And the gears make a 90 degrees angle. Okay, that's how it works. It's about gear systems. The gear systems in the illustration has 5 teeth, and like we explained, is the same gears. Calculate the revs per minute of the driven gear if the driver gear rotates at 1,500 revs per minute. Okay, this one has 5 teeth, and this other one has 10 teeth. So it's 1,500 revs per minute times the number of teeth on the input gear and the number of teeth on the input gear divided by the number of teeth on the output gear. And that equals what? 750 revolutions per minute. Right. If a driver has 15 teeth and the driven gear has 60 teeth, calculate the gear ratio. Okay, Natalie, speed advantage. Remember, we shared those formula yesterday of gear calculations. Okay. Let's go back to the calculation so that you understand. Calculate the revs per minute, revolutions per minute. This is the speed advantage. The speed advantage, yes. We are calculating the speed advantage. So we are given here, calculate the revs per minute of the driven gear. If the driver gear rotates at 1,500 revs per minute, revolutions per minute. RPM is revolutions per minute. So we are going to take the revolutions per minute that we are given and multiply them by the number of teeth on the driver gear divided by the number of teeth on the driven gear. Then the answer will be revolutions, 750 revolutions per minute. Now, this is the revolutions per minute of the driven gear. That is what we are calculating. So we take the revolutions per minute of the driver gear and multiply them by the number of teeth on both the gears. Then we get the answer for the revolutions per minute for the driven gear. Okay, we are calculating from this system. Okay, I see, Natalie, your problem is that I didn't demonstrate the formula for this 5 divided by 10. What does it mean here? It means the number of teeth on the 5 is the number of teeth on the driver gear divided by the number of teeth on the driven gear. So the formula will be the revolutions per minute of the driver gear, because we are calculating the revolutions per minute on the driven gear. So our formula will be the revolutions per minute on the driver gear multiplied by the number of teeth on the driver gear divided by the number of teeth on the driven gear. So that is how we will get the answer. The answer is the revolutions per minute of the driven gear. So we will say the driven gear is rotating at 750 revolutions per minute. That is our answer. Natalie, do you understand me now? Okay. If a driver gear has 15 teeth and a driven gear has 60 teeth, calculate the gear ratio. The gear ratio, this is the gear ratio. The gear ratio will be 60 divided by 15. Gear ratio equals the number of teeth on the driven gear divided by the number of teeth on the driver gear. So the answer will be 4:1. Nhlanhla? Yes, Nhlanhla. No, Natalie. Which will be 1,500 divided by 2, then that will give you 750. Because the answer that you'll get from this is 2. Okay. Right. This is your answer here. It's 4:1. Okay. Number of teeth on the driven gear divided by the number of teeth on the driver gear. So your answer will be a ratio because it's gear ratio. So it will be 4:1. What does it mean? Okay, it means for 1 revolution on the driver gear, there are 4 revolutions on the driven gear. Right. Consider a gear system where the driver gear has 25 teeth and the driven gear has 15 teeth. Okay. If the driver gear rotates at 100 revolutions per minute, calculate the speed of the driven gear. In other words, you are calculating the revolutions per minute of the driven gear. So you are going to use this formula. Let's see. So it's the revolutions per minute of the driver gear multiplied by number of teeth on the driver gear divided by the number of teeth on the driven gear. So the answer will be 165 revolutions per 167 revolutions per minute. Let me check this answer. Yes. Yes, yes, yes. That's good, Nhlanhla. What can you say about the input turning force at the driven axle compared to the input turning force at the driver axle? How does that change in this system? The input turning force at the driven axle. Okay. So the output turning force will be 3 times, will be 3/5, 60% of the input turning force. Okay. Right. This is the mechanical advantage. When we are talking about turning force, we are talking about the mechanical advantage, but the speed will be the speed advantage or velocity ratio. Okay. Right. Now let us look at the drawing. How do you draw gears in 2 dimensions? You will be asked to draw gears using graphical symbols for gears. Now, I want you to understand the graphic representation of gears, the different lines. Why do we use those lines? Okay. How to draw a gear wheel with 15 teeth. So if you can count these teeth, they will give you 15. Okay. Now, you have the 3 lines, 3 circular lines that you will make with your compass when you're drawing. Now, you have this inside diameter. Okay. Okay, here we know that that is your axle. And then you have this inside diameter. Right? Then from the inside diameter, you give another space. Okay? Then you have your pitch diameter. You make another circle. We call that your pitch diameter. Then you have the third line, which is your outside diameter. You are using your compass to draw these 3 diameters, right? Now, this is your pitch. This is your pitch, okay? Now, the pitch here is specified to be 7.5 millimeters. I'll show you how you measure that. Then, number of teeth is 15. Pitch circle, it's 35.8 millimeters. How do you, please practice this, okay? If there was no COVID, you could be practicing this in class. You would take your mathematical instruments and practice this in class. I think we have a message. Ma'am, are we gonna draw? Yes, Katlego. You will draw everything that we do here online. you must practice at home, except for those things that I will tell you that it's not important, because these are the skills that we have to go forward with. If we move to other classes, you know, if we study further, we must have mastered these skills. Okay, it's no use for us to go forward if we don't have these skills. So when you are practicing that, you make your pitch 7.5 millimeters, and then you know that your number of teeth is 15. The pitch circle diameter is 35.8 millimeters. How do you do that? Let me come here. You take your, to get those measurements correct, you take your ruler and your compass. You put your compass on your ruler like this with your pencil, of course. Then you measure the millimeters, and then you put the point of your compass accordingly. Then you start to draw like that. You will not achieve this accuracy if you didn't measure. So you start by measuring, okay? Then you will be able to draw a gear like this. Please practice it. Please practice it at home. Okay, that's how you draw your gear. Okay. Then the pitch is the space for each tooth. The pitch, it is the space for each tooth. The pitch diameter is the size of the circle that can fit all teeth. Okay, pitch diameter, the size of the circle. So this pitch diameter is 35.8 millimeters. You're going to put your compass like this and measure it so that you can fit all the teeth. The outside diameter shows the size of the circle that surrounds the teeth. The outside diameter. Okay. The inside diameter shows where the teeth are joined to the inner wheel. The inside diameter. That is actually where the teeth begin. That's the line from which you start drawing the teeth. The depth of the teeth is the difference between the outside and inside diameters. So after you have drawn these three diameters, it's easy for you to know that my teeth will start on the inside diameter and extend to the outside diameter. And you know how big your pitch is, the space between the teeth. The pitch circle diameter on this gear is 35.8 millimeters. The distance around the pitch circle of this gear is the pitch circle circumference, which is this is the circumference, okay. In total, it will be 112 centimeters. So the pitch or the space for each tooth is 112 divided by 15, that is 7.5 millimeters. Each and every tooth here will measure 7.5. You'll be measuring 7.5 millimeters for each tooth. You try and practice this at home. Only practice gives you practical skills. So in technology, you know you have practical skills. Okay. So you will be using these. You know, these drawing instruments, they come in different sizes. And I've noticed that, you know, the bigger the size, the better. But if you don't have the drawing instruments, please use mathematical instruments. They will serve the purpose. Okay. But it would be best if your parents could get you drawing instruments. Right. Now, how to draw a gear wheel. This is the graphic symbol for the gear. This one was just a gear with teeth. That's how you draw your gear with teeth. But here, you can be required to draw a graphic symbol of a gear. So, you will be drawing the inside diameter. Okay? Those are the specifications. Actually, if you can take your workbook, your Sasol Inzalo workbook, Uqonda workbook, you will check the activities, they are there in your workbook of how you are going to do it. If you don't have it, you can download it and then see these activities are inside your Sasol Inzalo workbook. Okay, that is the textbook from the department. Okay, it was developed for the department by Sasol Inzalo. So, it's okay, my darling Nhlanhla. If you have a different textbook, you can download this one. But I know that those textbooks which are approved by the Department of Education, they do have these activities. If you can't find it on your textbook, check out the Sasol Inzalo or Uqonda workbook, okay? You will find these activities. Then you practice these drawings. It's very important that you learn how to do this, because when you study further, it will be expected that already in grade 8 you did master these drawings. Katlego, it's Uqonda, grade 8. Grade 8. Grade 8. Or let me say technology. Let me add technology just for you to find it. Okay. Right. And then you draw the pitch diameter at 35 millimeters. So this one will be 27.5 millimeters, and the outside diameter will be 42.5 millimeters. So the pitch, it's 7.5 millimeters, number of teeth 15, pitch circle diameter 35 millimeters. Somebody was talking to me. Yeah, do practice these drawings. That's how you draw your gears. You draw one gear. Now, if you are to draw meshing gears, look at this drawing. The mesh, a gear mesh is when the teeth interlock. So if you can look at this part, this is where the teeth have interlocked. So if you look at this plan, oh, I'm sorry. This plan, it gives you your pitch circle diameter for the big gear and your pitch circle for the small gear. But the axes are aligned. The axes are aligned. It's very important because for the gears to mesh, you need this alignment. You need this alignment. And another important thing is the distance, okay? Because that will then have a bearing on the gear mesh, okay? So you measure these distances, the center distance, the pitch circle diameter of the driven gear, and the pitch circle diameter of the driver gear. And then you start drawing using your compass. You start drawing. The size and shape, okay, the spare gears will only mesh properly if the size and shape of their teeth are the same. That's very important. If you can look at these teeth and these, they are similar. In other words, the pitch and the depth of the gear on both gears are the same. And and the pitch circle circumferences of the two gears are touching each other. So you look at this gear mesh. So the teeth have to be the same. The line connecting the centers of the two gears is called the center line. Okay? This, it's connecting the two gears. So this is your center line. Center lines are drawn as chain lines. So this is a chain line with long and short dashes. Okay? So this is the center line. Another center line. Okay? That's how you draw it. So anybody who will be assessing your drawing will check if you used the correct conventions for drawing this. So when we draw a center line, we use this chain line with long and short dashes. The distance between the gear centers is shown on this drawing as the center distance. I said that is important for the gear mesh. The exact center distance of two meshing gears is the pitch circle radius of the driver gear plus the pitch circle radius of the driven gear. This. Okay. So this becomes very important in this drawing. You must learn how to do this drawing. Okay. So you must learn that the radius is half of the diameter. If, for example, the driven gear has 15 teeth and a pitch circle of 35 millimeters, the driven gear had 30 teeth and a pitch circle of 70 millimeters, then the center distance would be half of 35 millimeters plus half of 70 millimeters is equal to 7.5 millimeters, 17.5 millimeters plus 35 millimeters, okay? Then that would be equal to 52.5 millimeters. I tell you, grade 8, for this, you definitely need to get enough practice. We just hope that because you are learning online, you do see these skills and then you practice them at home, okay? And please find this workbook and try and work out and try and see these exercises from your workbook. You will see if you are getting better and better, all right? If I were to give you assessment for this, I would really add this. I would really add this. No, I can't. It can't be in the assessment for today because you're learning it for the first time. So everything that is in your assessment is something that you have already learned. Okay, Nhlanhla, don't be worried. Ukuqonda, Asanda, yes, ukuqonda. Right, and then here you are drawing meshing gear systems. Now, this is very interesting. This is what I want you to learn now. When you are looking, I've shown you the different radiuses, okay? Now, this is a graphical representation of a mesh gear, a gear train. Now, you have the 15-tooth driver gear and a 30-tooth driven gear, all right? So what is interesting here, these three radiuses, they interlock, okay? This is the inner diameter, the outer diameter. So the gear mesh is from the inner diameter, the gear mesh, because you see these lines are intersecting. Ne? So it is from the inner diameter of the driver gear is touching the outer diameter of the driven gear. So that's how you graphically represent a gear mesh. Okay, the driver gear has a pitch of 7.5 millimeter, number of teeth, 15 pitch circle diameter. Oh my goodness. Yes, so that is how you draw. That's how you draw your okay. I'm sorry about that call. All right. My car is in for service and I need to collect it. I hope that you will practice these drawings. Our lesson is to come to an end. And please look for Sasol Inzalo Ukuqonda workbooks and you will see these drawings and practice them. Bye.